Good morning, MB Debs. Yeah, so guys, we're coming on here for grade 11. Please double tap, screen double tapping, please. Let's get the likes up to 1000k. We'll only start when the likes are at 1000 specifically. So let's double tap. Green Bomber, hello, how's it? Hello. Hello everyone. Yes guys, please let's double tap on the screen there. We will start when there's 1k likes, 1000k likes. We'll start 1000k. Let's double tap, guys. Let's double tap, please. Let's double tap. Let's tap. When we had shalom, that melanin girl, let's double tap, guys, please. Let's get it to 1000 likes so that we can start. We are going to be doing corrections on the exponents that you saw on my page. There were some grade 11 exponent questions I put up on the page. We are going to be going through those so that we can consolidate the topic of exponents. We are going to consolidate the topic of exponents and thirds. Okay, grade 11s. Let's go. Okay, we are at 1k likes. So guys, grade 11s, we are going to go through one by one. These are problems that had been posted onto my homepage. I had posted them, I think the last 3 days these were posted, okay, and these are basically simplification of exponent type problems. So they were there on the homepage after one of the live lessons I had done, and the whole objective for those problems being posted was for the people who come into the page to actually see them, attempt to do them, and yeah. So we're gonna do them one by one, and we're going to start right there. Okay, please save this after Slibo. It's always saved and always on the YouTube channel, my guy. Always saved and always on the YouTube channel. You go and check it out from there if you so happen to miss the live. So we don't have time, guys. We have a lot of problems to go through. These are all the problems that were on that page. Okay, so we've still got a lot to go through. So we're gonna take it one at a time, and we are going to just pull them apart and see. Cool. So let's start right here. Okay. FF King, grade 8 maths on my other YouTube channel. Not YouTube channel, on my other TikTok page. There are 2 TikTok pages that I have which are called Maths is a Game. The first TikTok, one of the TikTok pages has a green icon. It's also called Maths is a Game. Find it. Then go and follow it. Okay, FF King. So please just go to my other Maths is a Game TikTok page. All right, it's also called Maths is a Game. I'm just going to show you right now, just a sec. I'm going to show you how that page looks like. This is the page, this one. Okay, so this is the one that I'm currently on. This other one is this one, Maths is a Game 5 to 7. Here it is. Okay, this is where I do only grade 8 and 9 lessons on. So if you want to be exposed to grade 8 live lessons, this is the page to actually come on. Secondly, if you specifically want support for grade 8 for the entire year, please go to this page, follow me, and then go and message me. Send me a DM and indicate, I am that guy, or I am that woman, FF King, that sent you 2 roses in the previous live. I want basically to be part of your WhatsApp group. Then I'll send you the details that pertain to that WhatsApp group. You can then escalate that information to your folks, your parents, and then they can actually decide as to whether, depending on that particular fee that the WhatsApp group has, would you like to be part of that group. And then what I will do is that if we are in agreement and your folks are in agreement and the fee is fine, you then can join and be part of my group, and then all the support for the entire year that is going to be afforded to the grade 8s and 9s during the course of the year will be yours. And you'll see when I send you the details, the specific details. So please, like I said, go to my Maths is a Game 5 to 7 BA2, the page there. Go to, first follow me, of course, and then message me. Please send me a message, a private one, and tell me that, okay, I'm that guy, the grade 8 and 9 lessons. Because in the WhatsApp group, that's where I send the schedule to the grade 8s and 9s as to when I'm going live, and any additional support like preparations for tests and exams, help and assistance with homework, and many more things. Because that is how basically we can work with the grade 8s and 9s. So this is just the TikTok page that is for that purpose. The one that I'm live on is for grade 10, 11, and 12. This one. Okay. So this one is for grade 10, 11, and also 12. This is the one that you guys are on at the moment. And so I'm going to do grade 11 exponents right now. Okay. And this is basically, like I said, these are problems that I had posted when, guys, I posted the problems here. Here they are. Okay. Posted these problems 1 day ago. All right, so here are the problems that I'm currently going to be doing. All right, they are there. Right, we'll do the corrections for these grade 11 exponent simplification type problems, and that will basically end our exponents, simplification of exponents and surds concept, so that we can move on to equations, which is the next thing that will be happening over the next few days, right, in the week. Okay. And also grade 11, if you are not part of my WhatsApp group, you are in grade 11 and you want support for the entire year, please do send me a DM on this page, this one, the one that you are on. You can send me a DM, let me know you are that person, you joined my live today, you like to be part of the WhatsApp group. I'll then send you the specific details, because in 2026 I'm doing things a bit differently than I did in 2025. Remember, 2025 or 2024, towards the end of the year, this is when this thing started. But this year, doing things a bit differently. So, thank you so much, FF King, for the 2 roses. I really appreciate the support. And please, guys, the support is appreciated when it does come here. Okay. All right, let's go. Let's start. So first and foremost, let's look at this problem. Okay. We have 27b to the power 9, c to the power -3, a bracket, all raised to the power -2/3. That is all over the square root of 9 to the power -1, x to the power -8, and y to the power 2. Now, guys, when you're looking at a problem, the first thing you need to establish is what is the relation, how many terms are in the expression. That is something that is very important. How many terms are in the expression? Remembering that terms are separated by a plus and a minus sign, but they are combined by a multiplication, division sign, and brackets. So the things that separate terms, plus, minus. The things that combine terms, multiply, divide, and brackets. So if we look at this is a fraction. So this means this is one entire term. We can look at the numerator and ask ourselves how many terms there. That still means in the numerator there's one term. Why? There are brackets. Okay? And what's inside is 27b to the power 9c to the power -3. This 27, this b, and this c are combined by a multiplication sign. So in between the 27 and the b to the power 9, we are multiplying. In between b to the power 9 and c, there's multiplication. But that multiplication we don't write out. It is there, and it is the glue that holds 27, b to the power 9, and c to the power -3 together. Then there's a bracket. Then we have an exponent, which is -2/3. This is what we call a rational exponent. Underneath in the denominator, we have a square root. It's all over 9 to the power -1, x to the power -8, and y to the power 2. This 9, this x, and this y are also combined by multiplication, the glue that combines 9, x, and y. So all in all, the two operations that are dominant in this particular problem are m and d. What do I mean by m? I mean multiplication. What do I mean by d? Division. So guys, when we have multiply and divide and there's no plus and minus, we are safe to say that, well, we need to look at this guy. Bad mess. Brackets, that's where we start. So if we're going to look at brackets, okay, because B means brackets, E means exponents. We work in that order. D, division. M, multiplication. So as we work, we're going to look at brackets. Brackets. The order is that we start off with the brackets. So in the numerator, we've got brackets. But inside these brackets, there's nothing we can do as far as simplifying. So the next thing we are going to look at is exponents. Exponents. Outside the bracket, we have an exponent, which is -2/3. So what we do is we apply that exponent. And when we do, we consider the sign, the number, and the letter. So let us apply this exponent whilst considering the what? The sign of the number itself, n, and the letters b and c. What we do is we distribute the negative 2 over 3 to the 27, to the b, to the c. All right, so let's do that. So 27, for instance, can be written as 3 to the power 3. If we multiply the negative 2 to the power 3, then it's to the power negative 2 over 3. You may be wondering, where is that coming from? There is a exponential law that says when a base is raised to an exponent raised to another, then what we do is we multiply the exponent. So this exponent here is going to be distributed by multiplication to all the bases that are here. All right? Okay, so grade 11s, that's something to note. Okay, speaking to the grade 11s here because we are looking at grade 11 simplification of exponents. So 27 is going to be changed to 3 to the power 3. How did we do that? It's because we know that 27 is a composite number, but we change composite numbers to prime bases. In grade 8 and 9, you learned about how to write a number as a product of its prime factors. If you want to convert that using a calculator, it's simple. You simply take 27, you then press equal, you press shift, and then you press fact. What does that give you? 3 to the power 3. What is 3 to the power 3? It is 27. You then, 27 is written as 3 to the power 3. You multiply negative 2 over 3 as an exponent with the exponent that is now available. So we use brackets to indicate that that is going to be multiplied. We do the same thing with b. b to the power 9, the exponent negative 2 over 3 multiplied with b to the power 9. c to the power negative 3, the exponent negative 2 over 3 is multiplied with c to the power negative 3 there as the exponent. So this is basically how we are able to sort the 27b to the power 9c to the power negative 3 that is raised to an exponent. We distribute the outside exponent to all the respective bases with their respective exponents. 27 we changed to 3 to the power 3. As I said, how did we do that? We simply said 27 is equal from the calculator. Then we press shift, then we press fact, and then voila, the calculator gives us the prime base factorization of 27, which is 3 to the power 3. So there we have it. b to the power 9 multiplied by 2 to the power negative 2 over 3. c to the power negative 3, we multiply to the power negative 2 over 3. The reason why we can distribute this exponent is because the relationship between 27, b to the power 9, and c is one of multiplication. It's combined by multiplication. So the distribution of the exponent is possible. There's another law in exponents that says if we have a base raised to different bases raised to different exponents, and there's an exponent on the outside, we can distribute the outside exponent to the respective bases. So this p gets distributed to m by multiplication. This p gets distributed to n by multiplication. So this only applies when we have what? Multiplication between different bases, and it also applies when we have division between different bases. This, guys, is an important law of exponents that you need to understand. It applies when there's multiplication between different bases. You distribute the exponent by multiplication. And it applies when there's division between bases and there's an outside exponent. You multiply the exponent. Okay? but it does not apply when there is a plus between bases and a minus between bases. We do not do the same thing when there's a plus in between or a minus in between bases. This only applies when there's multiplication between bases, you distribute the exponent, or when there's division between bases, you distribute the exponent. So that's why we are doing what we are doing here. It is informed by the laws of exponents. Now let's go down to the denominator. Grade 11. This is grade 11 exponents. Go down to the denominator. In the denominator, what do we have? We have the square root of what? 9 to the power negative 1, x to the power negative 8, and y to the power 2. We can rewrite this root. Okay, so you can look at this in one of two ways. One person can say 9 to the power negative 1, x to the power negative 8, and y to the power 2, and they can then change this square root to a rational exponent of to the power half. One way of approaching this particular question would be changing the square root to changing the root to a rational exponent. Where does the 1 over 2 come from? Remember guys, this is a square root. So that means in your denominator, you are going to have 2. This entire root is basically to the power 1. So that's why in the numerator, you have 1 over 2. Okay. So we converted the root form to a rational exponent. This goes back to the laws. If you have a to the power m to the nth root, you can convert the root to a to the power. Now this m becomes a m in the numerator. When you remove the root, the nth root becomes n in the denominator. This is how we convert a root to a rational exponent. We've covered this, guys, in the lessons prior to this one when we did the laws of exponents. So your obligation and responsibility is, if you missed the lessons before the one that I'm doing now, where we did the basics of exponents, go to my link in the bio. There's a YouTube channel link there. There are videos that I've done since December of the basics of exponents. Go and watch those videos. Spend some time watching those videos and get the basics sorted, so that as you move now and answer these questions, you can understand what it is that I'm doing. So I'm saying this root can be converted to what, guys? To half. The exponent half. The square root. In the denominator, we write 2. And then it's all raised in the numerator with 1 over 2. Now it means that I can apply the very same thing that I did here to the denominator there. So let's apply it. Okay, so let's sort out what's 3 times negative 2 over 3. Okay, do you see what that's going to give me? 3 times negative 2 over 3 is going to give me, if you don't know, guys, you can go to your calculator and say 3 times negative 2 over 3, so that you get the answers that are correct. Okay, so you get negative 2. So that means I'm going to be left with 3 to the power negative 2 times, same thing here, b to the power 9 times negative 2 over 3. Maybe you don't know, so you go say 9 times negative 2 over 3, because you don't know. If you don't know, you don't know, man. So the answer is negative 6. So you write b to the power negative 6. Same thing, negative 3 times negative 2 over 3. Go to your calculator. Negative 3 times negative 2 over 3. You see, negative times the negative is positive, you get 2. C to the power 2. Now remember, the same distribution is going to happen. The relationship between 9x and y is one of multiplication. So what do we do to the exponent? We distribute it using half we multiply by -1, half we multiply by -8, half we multiply by 2. So we do the same thing there in the numerator. So we're going to say 9 to the power -1, x to the power -8, and lastly y to the power 2. So we are distributing that exponent half to all of the respective exponents for the different bases. Okay, so for now, let's keep that 3 to the power -2, let's keep that b to the power -6, and let's keep that c to the power 2. In the denominator, my grade 11s, what are we going to now have? What's -1 times half? That's going to be 9 to the power -half. -8 times half. Okay, remember guys, use your calculator if you don't know what to do. -8 times half. Please guys, you'd rather use the calculator and be correct than to do nonsense that is nonsensical from the head. You see, -4. So I know that the exponent is -4. Y to the power 2 times half. Surely you guys should know that 2 times half is actually going to be 1. Okay, now we are here guys. We are here. Finally, we are here. So what I can see now is that 3 is a what? Is a prime base. Prime base. B to the power -6, C to the power 2. 9. Hey, 9 I can still change. So let's go and change 9 from the composite number that you see to its prime base. 9 can be written as what, guys? 9. Okay, remember, this is not a prime number. 9 is a composite number, a number that has more than 2 factors. We want to convert the 9 so that it is a prime base. What is 9 going to be expressed as a prime base, guys? Do you know? When we rewrite 9, 9 is going to be written as, let's see in the comment section if you guys know. Nine can be written as Mukwena Dora. Don't even write a question mark, Mukwena. If you are still asking question mark, then it means you are not sure, my guy. Thank you, Manwa. Thank you. You see, the boy Q, you guys need to be sure, man. Don't do this thing of being unsure. So 9 is 3 squared. Okay, and that to the power -half. No, it's not 3 to the power 3 simple. Be careful. Okay, 3 squared. Simple. 3 squared means how many 2's are we multiplying together? 2. How many 3's are we multiplying together? 2 of them. This represents the quantity of 3's that you are going to be multiplying. There's going to be 2 3's. It's 3 times 3 that gives you 9. If you are saying it's 3 to the power 3, remember 3 to the power 3 means 3 times 3 times 3. That's 27. 3 to the power 3 does not mean you are saying this 3 multiplied by that 3. Be careful, ne? Be careful. So 3 squared, which is 9, raised to the power -half. So 3 to the power -2, b to the power -6, 6 to the c to the power 2 over this 2 times -half gives me 3 to the power -1, x to the power -4, and y to the power 1. Okay. Then when we finish, guys, we have what we see: 3 to the power -2, b to the power -6, 6 to the power c to the power 2, 3 to the power -1, c to the power -4, and y to the power 1. There's a few things now that we need to look at. The relationship at the top, multiply. The relationship at the bottom, multiply. The line, divide. So we only now have multiplication and division alone. When that is the case, guys, when that is the case, we can apply the laws of exponents. Law number 1 and 2. Remember, law number 1 says when you have same bases and you are multiplying, you keep the base, you add the exponents. That's law number 1. Law number 2 says when you have a division of bases like this, you can retain the top base, a to the power whatever, then you take this one, it goes up. When the exponent for base a goes up to the numerator, the sign of to the power n changes to negative. So we are going to apply that logic here, because we can see that there's only a relationship of multiply in the numerator and multiply in the denominator. Then this line means divide. There's no plus or minus in between the bases. So law number 1 and 2 can be applied freely. So what I'm going to say, I'm going to say 3 to the power negative 2, and I'm going to raise this 3 to the power negative 1 up to the denominator. What happens to the sign of to the power negative 1 when it goes up to the numerator? This 3 to the power negative 1 had a negative sign. When it goes up to the numerator, what happens to negative 1 as an exponent? It changes from negative to what? To positive. So this is like me saying 3 to the power negative 2 plus this one. There's no 3, base 3 now in the denominator. Let us finish and continue now. What's negative 2 plus 1? 3 to the power negative 1, b to the power negative 6, c to the power 2 over x to the power negative 4, y. That is basically what we see. To finish, we are going to now use the negative exponent law. Negative exponent law, which works very nicely when the relationship is multiply and divide alone. Please take note now what is going to happen. When a base is raised to a negative exponent, currently this base is in the numerator. But what would happen here is that this base would be written now in the denominator. The exponent sign changes from negative to positive. And then next to that a, there's a 1 that we don't see. That 1 gets left behind in the numerator. So the answer for a to the power negative n is 1. The a changes position from numerator to denominator. The exponent sign changes from negative to positive. It's the same thing if we had 1 over a to the power negative n. This negative exponent can change to a positive exponent. We move the a from the numerator to the denominator. From the denominator to the numerator. The exponent that is negative changes from negative to positive. And then what gets left behind in the denominator is 1. The final answer is a to the power n, which is now in the numerator with a different exponential sign. This law is important because it applies to negative exponents. Any base raised to a negative exponent can be expressed as a positive exponent. How? We change the position of the base when there's a negative exponent. So if the base is in the numerator, the base goes to the denominator. The exponential sign changes from negative to positive. If the base is in the denominator, the base changes from the denominator to the numerator. The exponential sign changes from negative to positive. This is the law that we apply when we have negative exponents. So our final answer cannot be expressed as a negative exponent. Our final answer has to be expressed as positive exponents. So the question is, who is going to be moving their position in the numerator? Who is moving, guys? Who is going to change position? Is he going to change position? Is he going to change position? Is he going to change position? And then if we go down to the denominator, is he going to change position? Is he going to change position? Who is changing their position? So currently we can see this is 3 to the power negative 1. He must go because he has a negative exponent. Where is he going? I'm going down because I have a negative exponent. B to the power negative 6. Is he changing? Yes, he's changing because he has a negative exponent. I'm going down. Who gets left behind? C squared, because he has a positive exponent. Down here, who's moving? Is it x to the power negative 4? Yes, he has a negative exponent. I'm going up. Why? Is he moving? No, he's not moving. He's staying. Why? Because he has a positive exponent already. This is what we actually do at the end when we can clearly see from our fraction the relationship between the bases is multiply and divide only. Then the movement can happen. Guys, when there's plus and minus in between the bases, this movement cannot happen. If there was a plus and a minus between the bases, the movement cannot happen. The movement is exclusive to multiply and divide. The movement freely happens. All right, so 3 to the power negative 1 will become 3 to the power positive 1 in the denominator. But that 3 to the power positive 1, guys, we know most the 1 is there even if we don't write it down. It's positive anyways. B will now change to b to the power 6 in the denominator. Who joins them? The y that was already there. X moves. Where does he go? To the numerator. He becomes x to the power what? 4. Then c squared was already locked in. This is our final answer. This is our final answer. So what I've done here is that I have basically step by step unpacked for you what it is that we do when we are simplifying a exponential expression where it is clear that the only relationship that exists is one of multiply and divide between the bases. How we have to apply BEDMAS by looking at the bracket. If there's anything we can do in the bracket, we do it. But if not, then it means we move on to the next order of what we ought to do, and that is look at the exponent. Exponent outside the bracket, bases inside the bracket are having a multiplication relationship, then it means we apply that rational exponent to what? To the S and L. You see this in the movies, right? But now we need to take that movie that you see that is inappropriate, that has S, N, and L, and you know that you apply the exponent to the sign, to the number, and to the letter. So we did that. Apply the rational exponent by multiplication using this law. Multiply to the sign. There's no sign, it's positive, obviously, the sign. So there's no effect that it has on the positive sign. The number, we change 27 to the prime base, 3 to the power 3, using our calculator or our heads, because 27 can be converted to a prime base. B to the power 9, we apply that negative 2 to negative 2 over 3 as an exponent. C to the power negative 3, we apply the negative 2 over 3. In the denominator, we can convert the square root to its rational exponent. Because the square root is over every base here, the bracket will be raised to a rational exponent 1 over 2 because the square root is applied to everyone. Okay, I hope we are clear with that one, guys. Okay, and we can do that because the base here that basically combines 9x and y is multiply. Then we do the same thing. We apply this law. We apply the exponent to the bases. So that means brackets, exponents, done in that order. Do you see this, guys? Then the next thing we look at is division. Division. After B and E have been taken care of, we look at division. Now we come down here, we're like, okay, now what we have after having distributed, multiplied the exponent, we are here now. What do we now have? We need to look at dividing. Okay, that's where law number 1 and 2 come in, because when we have division and multiplication alone, laws number 1 and 2, together with this conversion of negative exponents to positive exponents, is very useful. Okay, but of course we still
finish the simplification. 9 can be converted to 3 to the power 2. We simplify further. And after simplifying completely, we are done, we are here. But we know that our answer must not be having negative exponent. Answer must be left with positive exponents when we simplify. Answer must be left with positive exponents. Okay, but we apply law number 1 and 2 where it's possible. The base 3 and the base 3, we can apply law number 2, division of bases. Keep the base at the top. We change the sign of the base in the denominator. So that's 3 to the power negative 2 plus 1 in the numerator. We get 3 to the power negative 1. Then ultimately, these negative exponents need to have applied the law that we've just spoken about. If a base is raised to a negative exponent and it's in the numerator, it moves to the denominator, the sign changes. If a base is raised to a negative exponent, it's in the denominator, we change its position to the numerator, the exponent changes sign. That's basically how from here we got our final answer. And it's basic, simple, straightforward, just like that. Guys, right now I don't really care about the maths. So honestly, I don't know. Okay, all I care about is that we follow BEDMAS if the relationship between the bases is one of multiply and divide alone. We start with brackets, we move on to exponents, move on to division, multiplication, and of course we don't have addition and subtraction in this particular situation. So it's BEDM, BEDM. All right, even with multiplication we did not have. So here we are just simply lying in our bed. BED. We are lying in our bed. As most of you right now, as you are watching my live, what are you doing? Where are you lying? Come on, let's be honest. I can just see some of you. I can see you. You are still wearing your nighties. You are wearing your nighties, guys. I can see you. You are lying on your bed. BED. You are lying on your bed. You are lying there. Yeah, you are lying there. I can see, like, yo, still wearing the 90s pajamas. Some of you don't even have pajamas. You are wearing the clothes that you were wearing from last night. You are wearing those clothes. Hey, all right. So yes, B means brackets, E means exponents, D division. We work in that order when simplifying exponents, having division and multiplication alone. Where there's no addition and subtraction, guys, please let us consider BEDMAS, right? Okay, hopefully you follow the steps. Let's look at the next question. Let's look at this guy. So once again, we first observe the situation. Grade 11, guys, grade 11. I repeat, grade 11. Grade 11's term 1 for maths, they start with exponents and surds. This is probably lesson number 5 of exponents and surds since December. If you want to tune into what has been happening in December, YouTube channel, link is in my bio. You can go and watch the previous live sessions that I've done. There's one video there that is a live lesson I did here, which was 4 hours, because there I was ironing out the basics from previous grades, grade 8, 9 of exponents. It's funny that those basics from grade 8 and 9 are the ones that actually fight against you in grade 11 when you do exponents. Most people are not confident in exponents and they are not fluent in exponents and surds. Why? Because the basics are not solid. The laws are not understood. They are not well applied. So, yeah. Let us continue this problem, grade 11s. I can see some of you that you are not in grade 11, you are in grade 12, and you are like, hey, I'm going to 12, but the basics are not sweet. I can see some of you are not even in high school. Some of you are in varsity. Some of you are just here to watch. Some of you are maths addicts. You are just here. You are just here. You are asking yourself the question, why am I even tuning into this? I'm not doing this now where I'm at, but I'm here. Hey, I don't know this maths thing. This maths thing is just has a pulling effect on me. Anyways, let's look at this question. So firstly, how many terms in the expression? 1. Remember, the line means 1. Okay, this line means division, but the fraction means 1 term. Then let's look at the numerator. How many terms in the numerator? 1 term in the numerator, because dot means multiply. Multiply combines things. In the denominator, how many terms? Dot means multiply. Multiply combines things. So we have 1 term in the numerator and 1 term in the denominator. Now let's look now at the specifics. We have the square root of a to the power 3. We have the 6th root of b. We have the cube root of a, and we have the cube root of b to the power 6. So in our heads, what do we think about? Bad mess again. Why? Because when we are dealing with an expression with many operations, divide and multiply, we need to apply BODMAS or BADMAS. Guys, the BODMAS that you guys learned in grade 8 and 9, BODMAS, the O part means the order, roots, and exponents. O means roots and exponents. So all roots and exponents are accommodated with the O. Are you with me, guys? The O. Okay? O. So now, when you think about BADMAS, you're like, do we have any brackets here? No, we don't. So the next item of operation will be exponents and roots. So we have roots with exponents, and we have been told that we can convert roots into exponents. How? If you have the nth root of a to the power m, you can write this root as an exponent. How? A to the power, this m belongs to the numerator. The root, whatever it is, nth root, that belongs to the denominator. Yeah, you see people like Kadada, someone comes into my life, they want to sell themselves. Yeah, Kadada, my guy, please, my guy, I please, my guy, please. You know, the least you can do, my guy, when you want to do something like this in someone else's life, you can ask first in the comment section, my guy. Not just come, you see, and then verbam. Hi, my guy, there's ways to do things. Yeah, well, that's where people like you, I just what do I do? I mute you and then I block you because you didn't even have the decency, my guy. You see, we're in 2026, but some of you still feel that you just can do what you want. Please, my guy, there's a way. I'm going to allow your thing. You can still, you see, now I'm going to do something. I'm going to pin your comment because I can see, my guy, you are someone who wants to help. But please, man, please have at least the decency of asking. Don't just verbal, man. Please, my guy, please. You know, because I know some of you use exactly lives like this to get your own agendas through. You know, hi, please, man, please, ne? Please, my guy, please. Okay, anyways, so I was saying, guys, we can convert. Okay, we can convert. Kadada, Shemem, you can look at Shemem, you can look at Kadada. Kadada does physical science. Hi guys, we high school physical science, one-on-one tutoring, homework assistance, as exam. Follow Kadada, guys. Me, I do maths alone. I don't do science. So Kadada is the Kadada data. Kadada. Okay. Yeah. Anyways, the a to the power m, the nth root, to be written, guys, as a rational exponent, grade 11s, we can write it as a to the power this m, whatever the exponent is there, that becomes your numerator. The nth becomes your denominator. We've just written our root into rational exponent. Are we together, guys? So this should be something we should know how to do easily. Vice versa, you need to know how to convert a rational exponent to a root form. This is an important skill to know in exponents because it will serve its purpose here. So let's come down here. We have the square root of a to the power 3. When we rewrite it, I think Alicia. Okay, let's pin Alicia's comment there. Is it a to the power of 3 over 2? Alicia, please don't ask. Confidently state. I want you guys to turn question marks into exclamation marks. 10 question marks to exclamation marks. Confidently declare your truth. Don't say, is it? You are still trying to ask from me. No. Alicia, you know what you know. I've just explained the concept, and from your understanding of the concept, you are saying what you are saying. Confidently state your truth, guys. I need you to become like that. A to the power 3 over 2. So 100% correct, Alicia. Very 100% correct. Now we have no ding dong. I don't do maths late. Why don't I do maths late? Because we have a crisis with maths, my guy or my girl. We have a crisis with mathematics, pure maths specifically. That's why I am devoting this channel only to pure maths. Yeah. Please, it's maths, pure maths, guys, pure maths. Unfortunately, my guy. Sorry, not ding dong. Ding dong, ding dong. Okay, b to the power. Now we change this. B to the power. What's the exponent that's here? It's 1. B to the power 1 over 6. You see? We're working here. We're working very nicely. B to the power. There's an exponent 1. The root is the 6th root. So it's b to the power. When we remove the root, it's 1 over 6. Over a to the power. There's a 1 there. Please, guys, that 1, it's like God. It's Sunday today. It's like God, unseen but present. Okay? And sometimes it's funny that learners don't know or don't understand or don't perceive that, there's a 1 there, unseeable, invisible, but powerful when we know it's there. 1 over 3 times b to the power what? 6 over 2. Okay. Any questions, guys, so far? Any questions so far? Yeah. So this guy is very handy. All right. Remember, we are lying in our beds, and we said when we are looking at the question, we can see there's a relationship of multiply and divide. We start with brackets if there are any. Okay, no brackets. We move on to the next thing, E, exponents. It also means roots. So roots and exponents. So exponents, exponents kind of present, but also obviously we convert the root form. We convert the root form to rational form. Root form to rational exponent form. Are we together? This a to the power m can be converted, the nth root can be converted to a, the same base, raised to the power. This m is your numerator. The root, if it's the nth root, then it's m over n. Square root, m over 2. Cube root, m over 3. Fourth root, m over 4. Let's come down here. Square root of a to the power 3. Convert this to rational form, a to the power, this 3 in the numerator. The square root means 2 in the denominator. Sixth root of b, b to the power, the 1, the numerator. The 6, the denominator. Cube root of a to the power 1, the 1, the numerator. The 3, the denominator. B to the power 6, the square root of b to the power 6, the 6, the numerator. Square root, what is there? 2 in the denominator. Are we clear now when we're getting these things grade 11s? You are asking me, where do you get the 6? Where do you get the 2? Where do you get the thingy? Where do you get the that? Where do you get the this? This is where I get the this. This is where I get the that. This is where I convert this and that. Okay, are we together now? Fine. Exponents have been applied. We move on to the next item, division. What do we have here? Division and multiplication. Here the multiplication, no effect. Here the multiplication, no effect because these are different bases. But the division, guys, we can simply confidently apply law 1 and 2 of exponents. Thank you, the maths teacher and tutor. Now, I believe that the maths teacher and tutor is another phenomenal TikTok maths teacher and tutor in the Hizzles in this TikTok platform. These are the people, guys, that I would want you guys to also associate yourselves with, because they will help you. I'm sure the maths teacher and tutor is doing the things, right? So you see, out of the generosity of my heart, thank you for the heart me, by the way. Out of the generosity of my heart, I'm going to say to those who are in this live lesson, you may feel it's more sweet to listen to the maths teacher and tutor. Please, guys, go and follow the maths teacher and tutor. Go and actually check out the maths teacher and tutor's content. Maybe the maths teacher and tutor also does physical science. It will be that much more of a benefit to who? To you. Are we together? To you. So please, guys, let's hold it right there. So now we are multiply and divide, guys. The laws, law number 1 and 2, can be applied freely because the relationship that exists between the bases is one of multiply and divide. Division, let us apply. Bases are the same, we are dividing. What do we know when the bases are the same and we are dividing? Okay, we can do this application of law number 1 and 2 here because there's no plus sign or minus sign in between the bases. It's only multiply and divide between the bases. So law 1 and 2 can be applied. Bases are the same. What do we do to the exponents when the bases are the same and we are dividing? Here, bases are the same. What do we do to the exponent when we are dividing? Hopefully we know, guys. Thank you, Shamam. 3 over 2 minus 1 over 3. Guys, 6 divided by 2 is 3. So I know this is going to be b to the power 1 over 6 minus 3. Guys, I don't waste time, me. I just grab my calculator. This here, I can just simply use my calculator and get the final answer. So I'm going to say, I know some of you want to do that maths and get the same denominator, but you know what? There's no marks for that. Look, 3 over 2 minus 1 over 3 from my calculator is 7 over 6. So I'm going to say a to the power 7 over 6. Same thing, 1 over 6 minus 1 minus 3. Calculator, hey, yeah, that's why I love you, calculator. I love you, calculator. Mwah. B to the power negative 17 over 6. Okay. Now, my only problem, what is my only problem? I cannot have an answer as a negative exponent. We remember that. So my final answer is going to be a to the power . Where does Mr. 17 over 6 go? He goes down there. Where? To the denominator. That's where he goes, Mr. Denominator. So the answer is a to the power 7 over 6 over b to the power 17 over 6. And honestly, guys, that is as simplified as I can potentially go. All right. Okay. All right, I don't know if there's any questions about that, but that is it. Okay, that is beautifully it. When bases are different, really we can't do anything. Remember, this guy was in the numerator, right? It's negative. Our final answer has to exhibit a positive exponent. So what happens to b? He changes position. He can do that freely because the relationship between him and a to the power 7 over 6 is one of multiplication. Okay. So we can do that. It's Ghana, it's the Casio calculator, my guy. The Casio calculator, the FXZ. So it's the Casio. It's just that it's old, my guy. So a FX82ZA plus. But let me tell you something, guys. There is now, so it's black, this one, it's Casio. But there's the white calculator. Yo. Those who have been in the industry know about the white calculator. It's a bit more expensive than the The black one, the white calculator, guys. Ooh, that one. It's fire. It's fire, that calculator. You can try and get what we call the white calculator. Hey, it has more features and functions than the black one, my guy. That one. Casio White. Get the Casio White. WWE OG the Bloodline Donald. What in the world? What is this guy spamming my? Are you spamming the live with Donald? What is this? Donald who? Donald Duck? Hey, this guy is. What? Yeah, look for the white calculator gun. You will be happy with your purchase. It's money well spent. I initially thought that calculator. How can that calculator be a calculator that learners can enter into the exam venue with? Because it's fire, that one. It's fire. It's Casio, ne? It's still Casio, but it's white. It is more developed than this one. Okay. So if A and B didn't have the multiplication connection, how were we going to do with the negative exponent? Let's just say, for instance, Shamam, since you're asking. Yes, there we go. That maths teacher and tutor knows about the calculator that I'm talking about. It does complex numbers too. Yes, it does, but obviously our learners are not interested in such, especially the CAPS learners. But yes, that calculator, it's fire. Let's say, Shamam, it was a to the power 7 over 6 plus b to the power negative 17 over 6. Yes, Jabuli, let's term one work. Then, Shamam, you see, we would say a to the power 7 over 6 plus 1 over b to the power 17 over 6. Then we would add these as if we are adding fractions. All right. We would add these as if we are adding fractions, so that from two terms we can actually get one term with a lowest common denominator of b to the power 17 over 6. So you would ultimately get an answer. Okay, I know some of you know that whenever you are dealing with a fraction, okay, this can be written as a to the power 7 over 6 over 1, and this is 1 over b to the power 17 over 6. So I know some of you, when you add fractions, you do butterfly, sort of like the butterfly. I've heard learners in my comment section say, no, when you're adding fractions like this, you just do the butterfly method. And I was asking what the butterfly method is. So you take this, you multiply with that. Learners are teaching me a lot on this platform. Because you see, the thing is, I'm not perfect in maths, I'm trying, guys. This times that, it's a to the power 6 times b to the power 17 over 6. This times that is 1 over this times that is b to the power 17 over 6. So this would actually literally be the final answer. And really and truly, there's nothing more we can do with this particular problem. We end right there. All right. So this becomes an addition of fractions, and what I simply did is I took the negative exponent and I wrote it as an independent, because remember, the plus sign separates the terms. Plus and minus separate the terms. So between bases, we now have a addition and a subtraction, which separates these two. So that means I'm going to have to convert the b to the power negative 17 over 6 as a separate base to a positive exponent. I told you, Moss. A base raised to a negative exponent can be written as 1. Okay, remember that 1 gets left behind, the a goes down, the negative exponent changes to positive, you see? So you have 1 over a to the power n. So that's how I got this. Then you add. Okay. Lwandle M, can you subtract the exponents of the bases? Where, Lwandle? Where? What do you mean? Where? Lwandle, are you talking about, are we still talking about this, my girl? Or are we talking about there at the end? are we, okay, Luandle, are you talking about this at the end? Okay, Luandle, listen. This is a to the power 7 over 6 times b to the power 17 over 6, right? You have a plus 1. How many terms are in the numerator? You have 1, 2 terms. This is b to the power 17 over 6. This b to the power 17 over 6 is 1 term. Okay, there's a rule when dealing with fractions that you cannot cancel across an addition or subtraction sign. So what makes it that we are not able to actually cancel this or subtract the exponents of these two bases is the fact that this here is separate from that there. All right, so this plus 1 over b to the power 17 over 6, we can't deal with this across an addition or a subtraction sign. It's not allowed. Okay, maybe to make this a bit more practical for you, Luandle, if I have 3 over 2 over 3, okay, my question to you, my dear Luandle, can I say this and that cancels, Luandle? Can I say that? Because if you are saying we can cancel across an addition sign, yay, problematic. Can I do this, Luandle? Right? Because there's a plus and a minus sign that's separating these terms, I can't cancel the 3 and the 3. Because this would be the same thing as you saying that, don't I divide the bases that are the same and subtract the exponents? Well, you can't do that if it's across an addition or a subtraction sign. We leave the answer like this. Just like 3 plus 2 over 3, we can't cancel 3 and 3 because we see that they are basically the same base. We can't do that. Or in other words, you can't say 3 to the power 1 and then you say, okay, no, we're going to say 3 to the power. We're going to raise the 1 minus 1 plus 2. No, guy. No. The answer we know is not 1 plus 2, which is 3. This here can't be. So what I'm saying is that if it's across an addition and a subtraction sign, cancellation or application of exponents cannot happen. The application of applying law number 2 cannot happen if it's across an addition or a subtraction sign. I hope you are listening to me here, Luandle, because the answer is not 3. We all know that 3 plus 2 over 3 is actually 5 over 3. Is 5 over 3 the same thing as 3? Luandle, are you still with me? Is 5 over 3 the same thing as 3? Unless you can say it is. I'm listening. I'm hoping you can respond. Luandle, in the comment section, are you still with me? And learners are making this mistake that you are talking about, Luandle. They are not observing the signs that are there. Plus and minus. Hey, be careful, my girl, be careful. Okay, I don't know if Luandle is gone. I don't know, Luandle, where are you? Luandle was the one asking. Now Luandle is not responding in the comment section. Okay, guys, can I just advise you? If you ask a question, and let's say really and truly it's an important question, maybe you have had a misconception and I explain that thing to you, please respond in the comment section. It helps me to know that, okay, you asked, I clarified. Okanya, you asked, you are still lost. Okay, thank you, Luandle. Yeah, I think, Luandle, it's because of that position you are lying in that bed, yeah, I think, yeah, it's making you lackadaisical, eh? Yeah, we're enjoying the lying in the bed, aren't we? All right, anyways. Yes, so winter, I hope you understand. Yeah. It's not winter. Yeah. Okay, let's move on to the next question. We are learning now. We are learning, guys. We are learning. I'm sure, guys, this problem is very nice. It's very romantic. It's very sweet. You guys will be able to do it. I know, right? Very cute problem here. So once again, what are we doing? We look at the entire expression. We ask ourselves, how many terms in the expression? How many terms? One term. One. Why? Because the line makes it one. The division line makes it one. Secondly, in the numerator, how many terms? Well, if you look at the bases, this base 2, multiply, square root, multiply, makes it 1. Multiply combines terms. In the denominator, how many terms? 1. So here we are happy because we have multiply and divide alone in the entire expression. So then we are going to say, okay, Mr. Bedmess, I'm obviously lying in my bed, but of course, since there's no addition and subtraction between the bases, the AS part, I'm not even going to bother myself. Let's get out of bed. B, brackets, E, exponents, D, division. Remember, E also stands for exponents and roots. And let's not forget this guy. Very helpful, this guy, in situation where we want to convert roots to rational exponents. Okay, so let's go. Brackets, we have none, so we are going to pass. E, exponents, a few. So let's come here and rewrite 2 to the power x minus 2. Convert composite bases to prime bases where possible. That's something also that we always observe if we have numerical bases. Convert all composite. What is composite numbers? Composite numbers are numbers that have more than 2 factors. For instance, 25 has more than 2 factors. 2 is not composite. 2 is a prime base. Okay, a prime number is a number that has 2 factors only, 1 and itself. So the factors of 2, for instance, are 1 and 2. 25 is not a composite base. A prime base. It's a composite base. It has more than 2 factors. So we are going to convert this. But first, let's just deal. 2 to the power x minus 2, you are fine. 25 to the power x is going to be 25. Convert this to exponent x over 2. This numerator, square root, denominator, the 2. Are we together? Feel me, my brothers and sisters? We applied this rule. This guy is going to be very useful for you. I'm telling you guys, very useful, this man. He's a useful man. Okay? He's a useful man. Very useful man, this man. So let's not forget him. Next, times 10. All right? We are going to convert him 10. When we convert him, all right, I guess just like we could have converted 25. Okay, maybe let's do it one at a time. We'll do the conversion just now. Okay, let's do the conversion of all these composite to prime now. 2 to the power x minus 2, because at least we were able to convert the root to exponent. So 2 to the power x minus 2, let's go to 25. 5 squared. $25 is 5 squared. How do we know? If we don't, 25 equal shift Mr. Facts 5 squared. Okay, this base is prime. This base 5 is a prime number, 3 is to the power 2. So we can just write the 5 squared, then x over 2 outside. Okay, 10. Let's go to our calculator. 10 is written as 10 is equal to shift fact. We can express 10 as such. And whatever we convert, guys, we make sure we place it in brackets. Why are we doing that? So that the law that follows can be applied, where we distribute the exponents to each respective base. Okay. Exponents and surds jabulile for grade 11. 8. 2 to the power 3. Press 8 in your calculator. You press equal, you press shift, you press fact, you'll get 2 to the power 3. Then you put it in brackets, you write x minus 1 outside. 5 is already prime. No problem. So we are still here. We have not gotten out of bed yet, right? We have not gotten out of bed yet. Right? We have not gotten out of bed yet. Brackets, all right? Exponents. There's that law now, this one, that we can apply, where if the relationship between the bases is one of multiply, we distribute the exponents. P times the m for the a, p times the n for the base b. So let's come and do that then with what we have there. X minus 2, 2 to the power x minus 2, no problem. 2 times x over 2. This 2 and this 2, they cancel. We're left with 1 and 1 because 2 divided by 2 is 1. That leaves us with 5 to the power x. We remove the bracket that way. Base 2, that's raised to the power 1. Remember, it's like God, unseen but present. So we are going to take this 1, distribute to the x, take the same 1, distribute to the negative 2. So we get 2 to the power x minus 2 as a result. 1 times x is x, 1 times negative 2 is negative 2. The 5, we do the same thing. There's a 1 here. So it's going to be 5 to the power 1 times x is x, 1 times negative 2, negative 2. All over what? Do the same thing here. So my chat, what will be the answer there? Let me see. I want to see what you guys. 2 to the power 3 raised to the power x minus 1. In the comment section, will you grace me with what you believe is going to be the outcome? 2 to the power 3 into x minus 1. Okay, I see you, Ghana. I'm guessing that's the exponent. All right. I see you as well. I see you, that melanin girl. As melanin and chocolatey as ever. Yeah. Okay. We good, right? All right. So that means we distribute 3 times x, 3 times negative 1. This is something sometimes learners forget. They distribute the 3 to the x, and then they don't distribute the 3 to the negative 1. So this is like a monomial by a binomial. So let's always make sure that we distribute the exponent to completion, okay? So 2 to the power 3x minus 3. Very good, guys. Very proud of you there in the comment section. Did very well. Times 5 to the power what? 2x. Exponents done. SNL done. Distribution done. Law, this one done. Next step, we are getting out of bed now. Division. Division of what, guys? All right. Law number 2. Division of bases that are the same. Okay. The only bases that we have here are base 2 and 5. So I'm going to collect those individual bases. Let's start with base 2. If you want, you can start with base 5. Doesn't really matter. Now I'm going to do a collection of all bases for their respective exponents. Base 2. Same base. Base 2 at the top. No sign change. X minus 2 as it is. At the top, bases are the same. When we are multiplying, we do what to the exponents? Add the same thing. There's no sign change. base 2 in the denominator. Guys, in the denominator, if we transport this guy up to the numerator, who changes? Everyone changes. So that means 3x is now going to be negative 3x. Negative 3 is now going to be positive 3. The sign change, because this is a direct application of these two. All right, the sign 3x, negative 3x, the sign of negative 3, positive 3. This is me just collecting everyone for base 2 so that I deal with base 2, done, did, finished. Multiplied, okay, by what? Base 5. Now we collect all the base 5 exponents. He is at the top, so he stays as he is. Multiplied, we are adding. He is at the top, stays as is, adding x minus 2. He is at the bottom. At the bottom, we experience what we call the what, guys? The sign change. So 2x is negative 2x. Then we are out of bed, officially and finally. Division together with multiplication was accommodated in this process because same bases divided, we subtract exponents. Same bases multiplied, we add. Sign change, division, same signs with addition. With multiplication. All right. Any questions so far, guys? You did such problems, at least from this stage, grade 10 as well. So it's not a new concept. It is really not a new concept. But if you are struggling, okay, one needs to indicate each, all right. And maybe some of you do it a bit differently in that you do the numerator and then later on you do the denominator. Guys, at the end of the day, the answers will be the same, all right? Me, I just prefer to collect everything using law number 1 and 2. I prefer to do that. Then I know with law number 2, with the division, all I am doing is a change of signs. This that was positive is now negative. This that was negative is now positive. I just do that with all the denominator. This that was positive is now negative in the numerator. Now we add like terms. Grade 8 and 9, you learned how to add like terms. You know x plus x is a like term. X plus x, x plus this x minus 3x. That gives you negative x. So x is not going anywhere. X is here to stay. Negative 2 minus 2 is negative 4 plus 3. That is negative 1. Then we go to the 5. X plus x is 2x minus 2x is 0. Then you have 0, then that minus 2. As we conclude, the bases are all negative. Answer 1 over 2 to the power x plus 1 times 5 to the power 2. Which is 1 over, we then settle it, 25. Split, this is 2 to the power x times 2. When you split these two, which gives you 1 over. Now you can multiply this 25 with this 2. That's 15. 50 times 2 to the power x. So that's an answer simplified completely. If they would have said to you, leave your answer in exponential form, then I guess, I mean, guys, at the end of the day, this is actually leaving our answer in the simplified exponential form. Okay, yeah. All right. Any questions, guys, at all that you guys have? If you have, ask. If you don't, I'm happy for us to continue. So please, guys, we go all through this very nicely and swiftly until we get to the very dead end. This is the situation. I've done 3 consecutive problems where in these problems, the last step, 3, 2, 1, this step, Ghana 2 to the power negative x minus 1. Do you see the exponents for both are negative? We are multiplying. The relationship is one of multiply. This base also has a negative exponent. So what is going to happen to these bases that are raised to negative exponents? They are all going to go where? Down. 5 to the power negative 2 is also going to go down. Who gets left behind at the top? 1. Okay, because 1 is multiplied to all of this. You don't see 1, but 1 is there. It's multiplied to all those bases. All right. So 2 to the power negative x minus 1, this exponent changes to positive when it goes down. This exponent changes to positive when it goes down. What about 5 to the power negative 2? He also changes to positive exponent. Guys, remember, what am I applying here? I am applying this notion of if a is raised to the power negative n, my final answer needs to be a positive exponent. So the base will change its position from numerator to denominator. The exponent changes from negative to positive. That's what happened here. 2 is raised to the power negative x minus 1. Moves to the denominator. The exponent changes from negative to positive. 5 is raised to the power negative 2. Since the relationship is multiply, this movement happens freely. There's no plus or minus in between the bases. That's why it moves freely. We leave 1 at the top and then 2 to the power negative x, positive. Negative 1, positive. Negative 2, positive. Okay. Hey, I hope you are with me, guys, here. How important this is. Then, as I said, 2 to the power x plus 1. The reverse of 2 to the power x plus 1 is the same thing as saying 2 to the power x times 2. I am splitting this to the original form. You multiply same bases, 2 to the power x and 2 to the power 1. What do you do to the exponents? You add them. This is just the reverse. By splitting, I see that there's 25 and there's this 2. 25 and 2 can be multiplied to give me 50. Then times 2 to the power x. I can't multiply the 50 and this 2. This base is committed to the variable x and I don't know what the variable x is. So this 50 is simply multiplied to 2 to the power x. I can't multiply the 50 and the 2 and say 100 to the power x. That's wrong. 50 is multiplied to 2 to the power x. I can multiply though this 25 and this 2. This 2 is freestanding. I can multiply it. Okay. KG, when am I going to end the live? I'm going to end the live at 10:30. Okay. So yeah, if you need to go, please go. Like I said, link of the YouTube channel is in my bio. I upload the live lesson as it is in my YouTube channel. You can rewatch whatever you missed. If you need to go to church, please. Okay, so guys, all the problems that we've done above had to do with multiplication and division between bases. Now let us step into another world for a little bit so that we can see the difference. Look at this problem. The fourth problem in this live. 2 to the power x plus 1 minus 2 to the power x minus 1 over 2 to the power x minus 1. So once again, we look at the entire expression, grade 11s. Okay, we look at the entire expression. Then we ask ourselves how many terms in the expression. The line means one term. In the numerator, how many terms? Let me stop there. In the numerator, guys, how many terms do you see? The numerator. I'm simply asking, in the numerator, how many terms do you guys behold? How many terms are in the numerator? Yeah. That melanin girl, thank you so much. Okay, there are 2 terms in the numerator. Why do we say 2? Plus and minus is what separates terms. Between bases, what separates terms is a plus and a minus sign. So that's 1, minus sign, that's 2 terms. If we have 2 terms, it means now we can't apply law number 1 and 2 as we usually would do. We can't, guys. It's not possible to apply law number 1 and 2 if there's a minus sign between terms. What we need to do now is we need to actually look at a different approach. BEDMAS is still in our heads, but of course we don't have brackets. We have exponents, but not with a bracket involved. Division is still there, but unfortunately we have subtraction in the mix as well. So it calls for a different approach. In the numerator, what we do is we split the base, applying law number 1 in reverse. We split the base using law number 1 in reverse. So you have 2 to the power x plus 1 here. This becomes 2 to the power x, 2 to the power 1. That's for your first term. Your second term, you have 2 to the power x minus 1. So you write it as 2 to the power x times 2 to the power negative 1. And then in the denominator, you have 2 to the power x minus 1. You can write it as 2 to the power x times 2 to the power negative 1. Something we note very quickly is that base 2 to the power x, base 2 to the power x in this particular situation exhibits an expression of 2 terms in the numerator where we have the same common what? Common base with an unknown variable. So we have a common base with an unknown exponential variable, or you could say an exponential variable. So then that means factorize. Now, different problems, some require you to take out that highest common factor, common base with the unknown variable. There are situations where that factorization is what is needed. Or there are some situations where a different type of factorization is needed. In a situation where we can see that this is a quadratic trinomial, and we are going to be looking at such a example very soon. So here, this one has a highest common factor, which is the common base with the unknown exponential variable in this situation, that 2 to the power x. So what do we do? Highest common factor, guys, whenever we have a highest common factor in an expression, what do we do to the highest common factor? We take it out. So let's take him out. 2 to the power x. Let's take him out. Take him out on a date, right? Yeah, take him out on a date. Very important to take him out on a date. Then what's left on the left hand side if we take out 2 to the power x? We are left with 2 to the power 1 on the left. What's left on the right hand side? We are left with minus 2 to the power negative 1. We close that bracket. That is all going to be over what? 2 to the power x times 2 to the power negative 1. Now what's nice is that when we look at the newly formed fraction, initially here at the top we had 2 terms, but when we take out 2 to the power x and then we have a bracket, my question is, in the numerator now, how many terms do we have? Majajitini, thank you. We have 1 term. So what does the factorization do? The factorization changes 2 terms to become 1. So when we take out a common factor, guys, there is something we are essentially doing. We are changing the situation with the fraction so that that can allow us to apply the laws for what is outside the bracket in conjunction with what we see in the denominator. So the relationship that exists now is 2 to the power x is multiplied to all of this. Multiply relationship restored. In the denominator, multiply relationship restored, which means law number 1 and 2 can be applied for what is external or for what is common. So what we see here is that 2 to the power x and 2 to the power x can actually be cancelled because it is not across an addition or subtraction sign. It is actually with a relationship of multiply that has been created through factorization. Okay, remember that cancellation leaves us with 1 and 1. So at the top now we have 2 to the power 1 minus 2 to the power negative 1 can be written as 1 over 2. What did we do here? Remember, a base raised to a negative exponent can be written as the 2 goes to the denominator. Okay, so we have a fraction. Then at the top we have 1 over 2. That's all going to be over. We are left with, in the denominator, 1 over 2 as well. So all you do here is you can just grab your calculator now and you can actually work out 2 minus 1 over 2. In the numerator, we have 3 over 2. That 3 over 2, remember, what does this line mean? What does this line mean, guys? I just want to shortcut this process. What does this line mean? We get 3 over 2, obviously, in the numerator. What does the line mean? This line, what does it mean as far as our operations are concerned? Yes, it means divide. So 3 over 2 is going to be divided by what at the bottom? By half. Okay. And obviously, guys, 3 over 2, okay, we do the, is it KCF? Keep, change, flip. Okay, I learned this in the live. Learners taught me this whilst I was teaching a live lesson. That's why I'm saying learners are beautiful. Learners are powerful, I promise you. Don't mess around with learners. I learned this thing in the live. I did not know this thing. KCF. I thought, I was like, what are these people? Why are they bringing KFC into the live? And then I know KCF said, KCF what? No, you keep 3 over 2 as it is. You change divide to multiply, and then you flip the fraction. It's like, learners. Then, guys, it's simple. So you say 3 over 2 times 2 over 1. That gives you 3. Keep common factor. The learner said keep, change, flip. All right. Dem Taka Chili is official. You are misleading us, Wena. Leonard said keep, change, flip, my guy.
or my girl, whoever you are. So yes, guys, please, nice. All right, common factor type problems. Okay. Sticks, is this pure maths or maths lit? Maybe you should tell us. What do you see when? Do you see pure maths or maths lit? Okay, but it's grade 11 anyways, whatever it is. Maybe Sticks, you can answer your own question there in the comment section. Is it pure maths or maths lit? 4 to the power n minus 9 to the power m over 3 to the power m minus 2 to the power n. Once again, another question. This one, it's really, you can see. So once again, what do we see here? Okay, it's not just multiply and divide, but we have what? How many terms in the expression? We have 1 because it's a fraction. If you look at the denominator, how many terms? How many terms in the denominator? Yo, guys, in the denominator you have 2. In the numerator, we have 2. So that means we have addition and subtraction. We have subtraction in the mix. Okay. Now, for this particular one, we always know in our heads, if there's a minus and a plus, there's going to be some type of factorization that's going to have to be done. All right. Okay, but with this problem, we can see 4 and 9 are not prime bases. Here, look at this problem. The base 2 was prime. This base 2 was prime. This base 2 was prime, which made it so easy for us to split because we could see there's something common when it comes to factorization. In our heads, the minute we see a minus sign or a plus sign, we think about factorizing. Something somewhere needs to be factorized. There's a type of factorization that has to be applied for. So for this problem, the splitting what is already prime helped us to actually apply highest common factor factorization, take out what's common, and then cancel. This one, base 4 and base 9 are not prime. So let's first change those composite bases to prime bases. What is 4, guys? Comment section, help me out. I need your help. 4, what is 4 as a prime base? And what is 9 as a prime base? We can't cross multiply KH4. Thank you, Clayton. Your Clayton is like giving me both. You don't mess around with Clayton, eh? 2 to the power 2. 3 to the power 2. Thank you, Clayton. Okay, thank you, Clayton. Then, of course, there at the bottom, we are still good, Moss. We are still good there at the bottom, no problem. We are still fine. All right. Now check me out, right? Then what I do is there's something that I know about multiplication. A times B is the same thing as B times A. We say multiplication is commutative. This was a grade 8 concept you learned. Multiplication is commutative. That word, commutative. The order in which you place something with multiplication doesn't matter. 2 times n is the same thing as n times 2. So what I've just done here is I've written 2 to the power, the n, the squared. So I know there's 2 of these 2 to the power n. There is 2 of these 3 to the power m. This is something that I'd like to see to know what is happening with the numerator. In the denominator, I have 3 to the power m minus 2n. Okay. If you look at this, 2 terms in the numerator. This squared, that squared. What do we call these two things? What do we call this term?
since it's raised to an even exponent. What do we call this term since it's raised to an even exponent? And what is this minus sign? Okay, because now I'm like, okay, I can't split, but there's a type of factorization that I can see at the top here. There's a difference here. This here is a something. This here is a something. What is this, guys? What type of factorization? Tender, difference. Beautiful Ghana, difference. Clayton, difference. No question mark, Clayton, be confident, my guy. Difference, difference of two squares. Now, the grade 10 learners that I've been teaching have been doing factorization, right? When there are rules attached to factorization, and the rules of factorization say whenever you factorize, the rules that you follow is that step number one, for two terms when you are factorizing, you need to first establish how many terms there are. So in the numerator, there are two terms that we know for sure. Secondly, after you establish how many terms there are, you need to then ask yourself, should I apply the sign change rule? Is it necessary to apply the sign change rule? Now, some of you are going to be like, what does this guy mean by the sign change rule? Is it necessary to apply the sign change rule? Do we know what the sign change rule is? And when you are going to apply the sign change rule, you must look at the situation not only here at home at the top, you must look at the situation at the bottom. And if the situation at the bottom is saying, hey, sign change rule is key, you better apply it. So the situation at home is informed by the situation abroad. Look at the situation at the bottom and ask yourself, is it necessary to apply the sign change rule? And maybe some of you are sitting here and are asking, what is the sign change rule? What does this guy even mean by that? Sign change rule for what? Guys, what I'm saying by the sign change rule, if you have, let's say, m minus n, right? Let's say you have m minus n and you have n minus m. And the question says simplify, okay? Two terms, okay? The sign change rule simply means this. You have m minus n. The sign change rule is this. The order of m minus n is not the same order as n minus m. But when you have a subtraction sign in between, you can do the following, for instance, in the numerator. Take out a negative sign in the numerator. Then you rewrite the order in the numerator as n minus m. Yes, you can do that, Clayton. You can do that. If you find working with exponents, you want to work with letters, you can let A be that and B be that. You can do that. Okay? But yeah, you can do that. That's fine. But then you just need to substitute back at the end. So guys, sign change rule, look at this. Took out negative sign. Then I change the order of the letters. That's all. The minus sign just remains, guys. You just simply change the order. Why? Kaloku, you can see there's an n minus m and your wish is to get rid. But look, guys, sign change rule is only applied when there's a minus sign in between terms. You can't apply the sign change rule when there's a plus sign. You apply it when there's a minus sign. So I take out a negative and I rewrite this m minus n now as n minus m. Now guys, check this out. If I take this negative, I put it back to n. What's negative times n? Don't I get negative n? Yes, I do. Take this negative multiplied by negative m. Don't I get the positive m that I had at the beginning back? Yes, I do. So does the sign change rule change this thing in any way? No, it doesn't. Okay, we are still talking about the same positive m minus m. Okay, so like I said, you take out a negative sign. Why are you taking out a negative sign? Your interest is to actually have the same order that you see in the denominator. We take out a negative, change the order. Now it fits the mold of what you see in the denominator. And then what can you do now? You can cancel, because we are not cancelling across a addition sign. We can cancel the bracket. And then what does that leave us with? There's a 1 and a 1, and of course negative 1 divided by 1. The final answer is negative 1. This is what we call the sign change rule. SCR. It's like a procedure, not medical. It's not CPR. It's, when people are out of breath and they need to resuscitate them. It's SCR. A procedure we perform so that we can form same brackets. That is what the sign change rule is. So this thing of sign change rule is useful in many aspects in mathematics, right? Because in situations like this, for instance, okay, I'm asking you, if you look at the two terms in the numerator, you first ask yourself how many terms there are. 2. Then, second question, should we apply the sign change rule? Is it necessary to apply the sign change rule for this particular expression in the numerator? Is it necessary? Guys, we only apply the sign change rule if it's necessary. If not, we move on to the next question and we ask ourselves, is there a highest common factor? And then if not still, after that, then we ask ourselves, what other type of factorization can we apply? That's where difference of two squares comes into picture. That's where trinomial factorization comes into the picture. That's where cubic factorization comes into the picture. That's where quadratic trinomial factorization comes to the picture. Okay? So that is like the order in which we go. Okay. All right. Does that make sense, guys? That is the order. Comment section. What do you have to say? I've explained what the sign change rule is. So is it needful that we apply the sign change rule in this situation? Do we need to apply the sign change rule, or is it not necessary? Okay, look at the order. 3 to the power m is first, minus 2 to the power n. But here, look, other way around. Okay. Do we need to apply the sign change rule? We have minus and we have minus. Do we need to apply? Do we need to get the order right? Or are we fine? We don't have to. We are good. Sign change rule needful? Okay, now I'm scared because people are silent. Like it's silent, silent, silent. No response. Circling course. Definitely we have to. We should, guys. There's no other way, right? We have to apply it. So what I do then is I take out a negative. Then I say 3 to the power m raised to the power 2 minus 2 to the power what? N raised to the power 2 over 3 to the power m minus 2 to the power n. Sign change rule has been applied successfully. Then I look inside the bracket. What type of factorization is this? It's a difference of what? 2 squares in the right order, because it will prepare cancellation. So now remember, with difference of 2 squares, we open 2 brackets. All right. Minus, we put a plus and a subtraction sign. 3 to the power m squared, the square root of this gives us 1 3 to the power m here, and another 3 to the power m, because remember the multiplication of 3 to the power m is what is going to give us back 3 to the power m squared, or 3 to the power 2m. Then the 2n squared, 2 to the power n times another 2 to the power n is what is going to give us 2 to the power n squared. What is that all going to be over? It's going to be over 3 to the power m minus 2 to the power n
in brackets. We make it 1. We make it 1 as well. All right. Okay, having taken out a common factor of 1. 1 is outside here. Here, -1 is outside. Now, that sign chain rule assists. Okay, so we applied SCR, then we applied dots in the denominator, highest common factor, taking out 1, and now it's very straightforward. The relationship, how many terms at the top? 1. How many terms at the bottom? 1. Cancellation can happen for common brackets. So that's why the sign change rule was so pivotal and important in our process of how we work. We are left with negative into 3 to the power m to the power 2n. Then we simply distribute the negative inside the bracket to get an answer that is simplified of -3 to the power m minus 2 to the power n. And that is our final answer. Okay. Questions? Okay, so those that decide to use K or P, other letters, you can do that, but don't forget at the end that your answer must not be in terms of those letters. It must be in terms of the exponents. So at the end, you need to substitute back. Okay, someone did indicate in the comment section, so what if I let A be equal to this 3 to the power m and let B be equal to 2 to the power n? And then I use the A and the B to simplify. Okay, I think it was Clayton. Okay, that is fine. Okay, that is fine. Okay, you can find the working of the exponents by letting the exponents be a variable, and then you simplify from there. But yeah, for me personally, I don't particularly like that for myself. Okay, though it works, because learners sometimes forget to substitute back at the end, and then they lose marks for not writing the answer in terms of the exponents, because they think that once they get that answer in terms of that A and that B, that's the answer, and they forget to substitute back. So rather, yeah. So this is one type of question where you have to take out a common factor, so highest common factor factorization. This is another type where you have to apply difference of two squares factorization. So you see the factorization is coming back. Now, then the grade 10 learners wonder why it's so important to understand the basics of factorization. And if those basics are not solid in grade 11, then guys, my question is, how in the world are you expecting to do well in maths? Okay, so with just 3 minutes left, I'm going to do the very last question for the day. Okay, so that at least the exposure is quite a bit. And then, yeah, I'm going to let you go because I also need to go. There's things that I need to do. Church that needs to be attended. Okay, at least I attend church at noon. Yeah, so I have to have at least the next 30 to 45 minutes to prepare and go. Okay, last one. 4 to the power x minus 3 times 2 to the power x minus 4 over 2 to the power x plus 1. Now this question is even more different from the first two, but when we look at it, how many terms are in the entire expression? There is 1. In the numerator, how many terms do we see? We have 1, 2, 3. 3 terms, guys, in the expression, okay, in the numerator. In the denominator, we have 2. Monty is like saying, why 3? Because this problem has 3. Why? What a question. Okay.
terms are separated by a minus or a plus sign. So 4 to the power x, this is a minus sign that separates 4 to the power x and this term. This is 3 times 2 to the power x, that's one term, because multiply combines terms. This is another minus sign, this is the third term. Okay, then in the denominator, how many terms? 2 to the power x, this is plus 1, there are 2 terms in the denominator. Okay, hopefully now Monthly you understand. Didn't see the dot? Well, the dot sees you. Okay, there's the dot. Let's just make sure that it's clear now, that you can see it well. Okay, so 3 terms means we have a trinomial. And that's on the 4th of January. Yes, yes, Pasadena. Yes, indeed. Are you happy? Are you okay? Seems like you're stressing there. I see that face that you've written there, January at the end. Why are you weeping? Okay, so if we look at the denominator, 4 can be written as 2 to the power 2 x. 3 times 2 to the power x minus 4. So I'm looking at where the variable is 2x, where the base is, all right? This is all over 2 to the power x plus 1. And I know there's some type of factorization I'm going to have to apply here. So the first question had highest common factor factorization. The second question had difference of 2 squares. This question, we have a trinomial. And what we observe, guys, is that for different terms, for different terms that have the same base. Remember, this is your first term, this is another term. But for different terms where the base is the same, there's something that we are observing with the same base, the same prime base for different terms where the exponent is concerned. If you look at the coefficient of x here, it's 2. If you look at the coefficient here, it's 1. So we have a coefficient of 1, we have a coefficient of 2. So this is 2 times this. This is 2 times that. The minute, guys, you have a situation of 1, 2, 3 terms, where with your first 2 terms with the same base, the variable exponent, one coefficient is 2 times the other one. That immediately shouts to you that we have a quadratic trinomial. I repeat, 2 to the power 2. The focus here, Ghana, is to focus on where the variable is. We do not bother ourselves with the last term because it's a constant. What we are interested in is that these 3 terms are what we refer to as a quadratic trinomial. We have the emergence of a quadratic trinomial here. And maybe when I rewrite it, you are going to see that much more. So 2 to the power 2 can be written as 2 to the power x squared. So there are how many 2 to the power x's? There are 2 of them. Multiplication is commutative. That's why I'm saying when the coefficient of that x, you can see for the same base, one is 2 times the other one. That's when you know quadratic trinomial. Furthermore, because there's a constant term there, all right, which is a separate term that does not have a variable exponent. 2 variable exponent, the coefficient is 1. 2 has a variable exponent, the exponent is 2. So when one variable is twice the other, that immediately says to you, we have a quadratic trinomial. So rewritten, 2 to the power 2x is written as 2 to the power x squared minus 3 to the power 2x minus 4. Hey, I'm sure you can see my trinomial. In the denominator, I have 2 to the power x plus 1. So I'm going to factorize this numerator. This is my square term. This is my k, and then this is my constant. So some people let k be equal to. Me, I don't really like the k thing, but I'm going to show you with the k thing, or if you decide to use another letter to factorize, because some people feel it's simpler when they do it like that, okay? So what we can do here at the top, we can see that there are 3 terms. This is a quadratic trinomial. How did we establish that? Because we saw that for one variable, the coefficient of that variable is 2 times, it's twice the other one. So that means a 2 to the power x and a 2 to the power x will give me back this. All right. -4 is the constant. This negative means I'm going to have different signs in my bracket. All right. The highest factor in my bracket is going to have a negative sign. So I'm going to check the factors. The highest factor is going to have this sign. So I'm going to check the factors of 4. I have 1 and 4. I have 2 and 2. The highest factor we said is going to have a negative sign. The other one has a positive. So which one, when I add together, because the multiplication of these two, or the multiplication of these two, will both give me -4. So we have no problem with the last term. Multiplying will give me the last term. But which one, when I add, will give me -3? Is it 1 minus 4? Or is it 2 minus 2? What's 1 minus 4? 1 minus 4 is a -3. What is 2 minus 2? It is 0. So I think my factors that are going to feature in the bracket are definitely 1 and -4. So in the bracket, guys, the highest factor is going to have a negative sign, and then we're going to have a 1 there. I'm sure now you can see in the denominator something is the same. 2 to the power x plus 1. I put a bracket around it to make it one term, because that's me taking out my highest common factor in the denominator, which is 1. Now cancellation can happen without any problems. Do you see? This thing is not difficult. All right? Does that make sense, guys? Grade 11. This is not difficult. Okay? Simplification of exponents. Quadratic trinomial factorization in exponents is made possible when you have 1, 3 terms, 2, the base that is the same for your different terms exhibits for the variable a coefficient that is obviously 1 is 2 times the other one. If we multiply 1 by 2, we get 2. If we divide 2 by 2, we get 1. It's like even if we had 4 here and we had 2. This would also mean that the coefficient of the variable is 2 times the other one. It's like even if we had 6 here and we had 3. For the same base, the 1 exhibits the multiplication 2 times the other one. Here, if you have 8 as an exponent for the same base and you have 4 for this same base, it's still a quadratic trinomial. One coefficient is 2 times the other one. So this is how you know it's a quadratic trinomial. With that constant, it means you can factorize. Okay. So the factorization of this trinomial is 2 to the power x minus 4 into 2 to the power x plus 1. This is all over 2 to the power x plus 1. Now you can simplify and cancel, leaving you with 1 and 1. So your final answer is 2 to the power x minus 4. Guys, this is it. All right, for today. Thank you so much. I will see you tomorrow, grade 11th, with another live lesson where we are going to finish off these problems. These problems are in my TikTok page. All right, they are posted there. If you want to go ahead and do them ahead of me before I do them on the live, go ahead and go and do them. All right, the recent video, the picture video on my homepage is these problems. So I'll see you tomorrow in the morning. It's Monday, so I'll see you tomorrow morning at 7 a.m. Let's try 7 a.m. and finish off this thing. Okay. Thank you. Yeah, grade 10. Obviously, this here, what I've done so far, all these problems are relevant to grade 10. Okay. So you can try and do this one. I didn't do this one. Okay, I did this, that, this. Okay, I didn't do that one, number 5. I did this and that. I haven't done 8, 9, 10, 11, 12, 13, 14, 15. We'll be doing those tomorrow. You can go ahead and do them and have fun with them. Okay, thank you guys. It was great. And I hope you guys will have a beautiful Sunday. Please, if you can, do support the live creator. It's really helpful there when you guys can, if it's possible. If not, thank you for the likes. I think we ended the live on 12.1k likes today, so quite a phenomenal feat there. We had jumping between around 80 people in the live to 155, I think, at best. So it was a good live. I think definitely a good live. Hope you guys were able to gain a lot there. And yeah, I hope that will actually solidify your personal understanding of the maths. Go and practice more problems. You guys have textbooks. You go and grab those textbooks. You grab what's there. You just you live it up. You live it up, guys. You make sure that you are pumping, so that at the end of the day, remember, if the concepts are understood, now what is left is for you to apply the concepts through doing various problems. All right, so that at the end of the day you can see that, okay, I actually do know how to do this. It does make sense, and it is not just something that is vague and ununderstandable. Right? Yeah, this is how we started. We started off here with just questions that have only multiply and divide. Okay, only multiply and divide. Only multiply and divide. And then from there we transitioned into questions that have plus and minus. Plus and minus with the divide in the mix. We saw how splitting the base and highest common factor, when we have to apply highest common factor factorization, how that looks like. We saw when we have to apply sign change rule, dots, how that is like. And then lastly, when we have to apply trinomial factorization, how that is like. When we screenshot the other questions, that melanin girl, as I said, these questions are on the most recent picture video that I posted on my homepage. So if you go to my homepage, there's a slideshow of 2 pictures. They have these questions. They are there on my homepage. Okay, exponents and surds, game challenge grade 11. Okay, it's been picking up. I think it's been picking up. Okay, it's been picking up. People have really been, I think, checking out the picture videos, and it's just that there's no comments. People have only commented on the grade 10
picture slide video. Someone even said that, hey, these problems are too difficult, and I'm thinking this learner is going to grade 10, but he's saying grade 9 factorization seems difficult, and I'm like, yo, we're going to be starting off on a very not so great foot. So please guys, the questions are there. There's even another page on the video itself of more questions. Go check out those questions. It includes also your surd and root questions, all right, which are based on the live lessons that we've covered. So I want you guys to actually go and make sure you verify and confirm what you have learned through the problems, doing them. So tomorrow we'll finish off these problems in the live lesson that we'll have. Okay, thank you again, and thank you again and again and again. Okay.